this lesson, we'll look at functions and their inverses. At the end of this lesson, meaning after going through this presentation, you should be able to demonstrate the ability to work with various types of functions and relations, including inverses. Explain what an inverse function is. You should also be able to find the equation of an inverse function. Be able to investigate and generate graphs of inverse relations of functions, in particular the inverse of y equals to ax plus q, which is a straight line, and y equals to ax squared, which is a parabola or a quadratic function. You should be able to determine which inverses are functions. Not every function, every inverse is a function. So you should be able to determine which inverses are functions. Restrict the domain of a quadratic function to make the inverse a function, meaning that when an inverse is not a function, you should be able to restrict the domain so that the inverse becomes a function. Let's start by revising a function. A function is a relationship between x and y, where for every x value, there's only one y value. So how can we determine a function or identify a function? A function can be identified using set of ordered pairs, as we discussed, and a vertical line test in graphs. If a vertical line intersect the graph more than once, the relation is not a function. Right. So if a graph is a function, what type of a function? We use horizontal line test to check what type of a function. To determine from the graph that represents a function whether the function is a one-to-one or many-to-one. We have two types of functions, one-to-one or many-to-one. A one-to-one function, if the horizontal line cuts the graph in one place only. Many-to-one, if the horizontal line cuts the graph in more than one place. Let's also look at function notation. F of x. F of x equals to 3. What does it mean? This is read as f of x equals to 3x. The symbol f of x is used to denote the element of the range to which x maps. In other words, the y value corresponding to the x values are given by f of x. Therefore, f of x represents y or the range. For example, if x equals to 4, then the corresponding y value is obtained by substituting x equals to 4 into 3x. For x equals to 4, the y value is f at 4 equals to 3 times 4. Where is x? We put 4. So 3 times 4 equals to 12. The brackets in the symbol f at 4 do not mean f times 4, but rather the y value at x equals to 4. Example number 1. Consider f of x equals to 2x plus 3. Determine the value of f at -1. So equals to, where we substitute x as -1. So we have -2 into -1 plus 3, which is equals to 5. Example number 2. F of x equals to x squared minus 2x plus 1. Right, determine f of -2. So what does this mean? It means where we see x, we put -2. So we have -2 squared minus 2 times -2 plus 1, which is equals to 9. So this is the function notation. Your f of x represent y. Now let's look at inverse functions. What is an inverse function? An inverse function is a function that will undo anything that the original function does. In the most general sense, are functions that reverse each other. Right, let's look at inverse function of one-to-one, a linear function. Consider the function f of x equals to 2x minus 4. Right. It is clear that f is the rule that transforms given values in the domain x values into values in the range using the rule 2x minus 4. For example, if x equals to 3, then the function f transforms this x value into a corresponding y value in the range as follows. F of x equals to 2x minus 3. We substitute minus 4. We substitute x as 3. So therefore we have f of 3 equals to 2 times 3 minus 4. Which therefore y equals to 2. If x equals to 3, then y equals to 2. So now let's look at the reverse. We can reverse this by using 2, which is the y value, to get 3, which is the x value. The rule that reverses this process and transforms 2 back to 3 is called the inverse of the original function f of x equals to 2x minus 4. This rule is obtained by interchanging x and y in the equation y equals to 2x minus 4 and then making y the subject of the formula. The new function is called the inverse function of the original function f and is denoted by the symbol inverse of f. Right, it's important to note that the negative 1, this is not f to the power to the exponent negative 1. This represents the inverse of f. How to find the inverse function? Firstly, replace f of x with y, swap x and y, solve for y in terms of x, replace y with the inverse of f of x if the inverse is a function. Now let's look at how to find the inverse of a one-to-one function. Example, if f of x equals to 2x minus 4, find the inverse of f of x. Firstly, we replace f of x with y. Then we'll have y equals to 2x minus 4. Instead of f of x, we put y equals to 2x minus 4. Swap x and y. So we swap x and y. We'll have x equals to 2y minus 4. Then we solve for y. To solve for y, then we can put our y on the right hand side and left on the, x on the left hand side. Then we take 4 to the left. So we'll have 2y equals to x plus 4. Then we divide by 2. We get y equals to x plus 2, x plus 4 over 2. Right. Then from there we replace our y with the inverse of f of x if the inverse is a function. Now let's look at how to plot the inverse of a one-to-one. Sketch the graph of f using the key features, which is the original graph. X-intercept, put y equals to 0. Y-intercept, put x equals to 0. Draw the line y equals to x. This is the line of symmetry, the reflection line. Reflect key points on the graph of f above and on the line y equals to x to sketch the graph of the inverse. Now, let's look at how to plot an inverse function of a one-to-one. So it's important to note that a function and its inverse are reflections of each other about the line y equals to x. Right, this is the line y equals to x, the red dotted line. When x equals to 0, y equals to 0. When x equals to 1, y equals to 1. X equals to 2, y equals to 2. So it's the line y equals to x. Right. Let's look at y equals to 2x minus 4. How to plot the graph. So y-intercept, y equals to 2. For y-intercept, x equals to 0. Therefore, y equals to 2 times 0 minus 4, which is equals to minus 4. So there's the y-intercept. Then for x-intercept, we put y to be 0, then x equals to 2. Then there's the x-intercept. Then from there, we draw a line that passes through the two intercept, which is the graph of y equals to 2x. Now, let's look at the inverse. Reflect the key points on the graph of f above the line y equals to x to sketch the graph of the inverse. So we are going to reflect the 2 points, the 2 key points, which is 2, 0, 0, minus 4. So we'll have 0, 2 instead of 2, 0, we've reflected, and then minus 4, 0. Then from there, we draw the inverse of f of x. Conclusion, inverse function 1-to-1. Notice the x-intercept of the original function is the y-intercept of the inverse, and the y-intercept of the original function is the x-intercept of the inverse. X and y interchange. The domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. So the domain swaps with the range. Inverse of 1-to-1 functions are also functions. The graph of the inverse function is a reflection of the original graph about the line y equals to x, the axis of symmetry of the two graphs. It should be clear that the inverses of 1-to-1 functions are also functions for all real values of x. However, the situation changes with many-to-one functions. With many-to-one functions, what happens is that the graph of the inverse relation is not a function. The only way to ensure that the inverse relation of a many-to-one function is itself a function is to restrict the domain of the original 1-to-1 function. This means that you have to restrict the domain so that the original many-to-one function becomes a 1-to-1. So we'll look at this in the next slide. Let's look at the inverse function of a many-to-one. So what is a many-to-one? In many-to-one, 2 or more elements of the domain are associated with the same element of the range. Each x value is, however, still associated with only one y value. Let's look at this example. Consider the function f of x equals to x squared. So to draw a function of many-to-one, first we look at the shape. For a parabola, first look at the shape. A is greater than 0. Therefore, our graph is concave up. And then we look at the axis of symmetry. X equals to 0. Turning point 0, 0. Intercept 0, 0. Right, to draw the graph, okay, we can also look at the table. So when x equals to -1, y is 1. X equals to 0, y is 0. X equals to 1, y is 1. So if you look at the table, it shows that this is a many-to-one because we have many x values, which is -1 and 1, gives us one value, which is 1 and 1. So let's look at how to draw the graph. So to draw the graph, so we start with the first arm. We start with the only one arm, and then we draw the other arm of a parabola. Right. Let's look at how to draw the function of a many-to-one. F of x equals to x squared. So firstly, we start by replacing f of x with y. Then we interchange x and y. Then we have x equals to y squared. The y values are now independent with the x values dependent. Therefore, y squared equals to x. Then to solve for y, we introduce square root. Then we have y equals to plus or minus x. And don't forget that your x must always be positive, because if x is negative, we'll have no solution. Right. The graph of y equals to plus or minus square root of x is not a function because a vertical line test will cut the graph 2 times. So if you check the red line, which is the vertical line, it cuts the graph of y equals to x plus or minus square root of x 2 times. Therefore, it's not a function. So we'll need to do something to the graph of y equals to x so that when we determine the inverse, this inverse will also be a function. Now let's look at how to make an inverse of a many-to-one function to be a function, because an inverse of a many-to-one is not a function, as we've shown in the previous slide. So to make the inverse of a many-to-one function to be a function, we restrict the domain of the function to make its inverse to be a function. We only restrict the domain. We take certain part of the x values, not all the x values. Like, let's look at the situation. For f of x equals to x squared, like the previous graph, so we've restricted the domain. So our x values will start from 0 up to positive infinity. And our range remains the same. We don't change the range. So we only look at the x values from 0 up to positive infinity. So it's as x is greater than 0. So we don't look at the negative side. So the dotted part of arm shows that we didn't use the negative. We only deal with the positive. So our graph will start from 0 with the x values from 0 up to positive infinity. And our range will remain the same, is y is greater than 0. So it is clear that the inverse of the graph of function f of x is equals to 0, where x is greater than 0, is also a function. Notice too that both graphs are also one-to-one functions. If you look at our original function, y equals to x squared, we only took the positive part for x, the x values. And the inverse will be y equals to square root of x, because the domain is x is greater than 0 and our range is also the same. So these two graphs are reflected on the line y equals to x. So the equation of the inverse function is defined as the inverse of f of x equals to square root of x, where x is greater than 0. So this is the situation where we restrict our domain. So let's look at another situation where we restrict the domain. In this situation, to restrict the domain, we only take the negative domains. So our x is less than 0. Don't forget that our range remains the same. We don't do nothing to the range. Right. Restrict the domain of f of x equals to x squared as follows. f of x equals to x squared, where x is less than 0. Once again, the range of the restricted function is the same as the range of the original function. It is clear that the inverse of the graph of the function f of x equals to x squared, where x is less than 0, is also a function. So this time we only took the part of the graph where x is less than 0. We only work with the negative side. So its inverse will be y equals to negative square root of x. So the equation of the inverse function is then defined as the inverse of f of x equals to negative square root of x, where x is greater than 0. So don't forget that the two graphs are reflected on the line y equals to x. Looking at the inverses of functions many-to-one and one-to-one, we find that one-to-one functions have inverses which are functions. If a function is not a one-to-one, the domain of the function must be restricted so that the portion of the graph is one-to-one and the resulting inverse will be a function. So we always restrict the domain of a many-to-one. We don't restrict the domain of one-to-one. We restrict the domain of a many-to-one function so that it becomes a one-to-one, and so that its inverse also becomes a one-to-one inverse function. The domain of the function is equals to the range of the inverse function. The range of the function is the domain of the inverse function. So the domain interchange with the range for a function and its inverse. Right. So if the two graphs are symmetrical about the line y equals to x. So if the two graphs of the function and the graph of its inverse are drawn on the same set of axes, and one makes a fold along the line y equals to x, then the graphs will lie exactly on top of each other because the line y equals to x is symmetrical. The table below provides reference to this topic in grade 12 textbooks. Right, use different textbooks and this presentation. Do different exercises from different textbooks and examples and compare. Thank you very much. Enjoy.